We've made it to question number 5 on the Review 2 worksheet for stats probability. Question number 5, the table below shows the results of a study for a new medicine that is supposed to prevent headaches. I think you've seen this table before. What is the probability that a randomly selected person from the study, so every question after this is going to be selecting a random person from this group of 100 people surveyed, to figure out what the probability is that you'd pick a particular person from this group. So we've got columns, they took medicine or they didn't take medicine, and rows, they got a headache, they didn't get a headache. We see that we've got a total survey of 100 people here. Let's go with the first one. What's the probability that we pick a person from this group of 100 and they took the medicine and got a headache? They took the medicine and got a headache. So took medicine and got a headache. Well, we've got took medicine, that's one row being mentioned. And we've got a headache, which is one column being mentioned. And they're connected with the word and, which means we are dealing with joint probability. Joint probability. So joint probability, we know the only one that doesn't use the grand total is conditional. That means we're going to have 100 in the denominator. How many people took medicine? Here we go. Took medicine and got a headache. That's 12 people. Took medicine and still got the headache. 12 out of 100 is 0.12, which is 12%. I love dealing with percents when you have 100 people or 100 in your denominator, because you can just do the math in your head. All right, next one. Did not get a headache. What's the probability of picking a person and they did not get a headache? Well, in this case, they only mentioned one category, no headache. That means we know one category. That means it's going to be marginal. Marginal probability, which means, again, I already know my denominator is going to be my grand total. And marginal did not get a headache. Take a look at your table. How many people did not get a headache? 73. Remember, marginal means you take the number from the margins. So 73, that's going to be 0.73 or 73%. Next one. Assuming they did not get a headache. Assuming, there's my key word. I already know this is going to be conditional, which means, class, I already know my denominator is not going to be the grand total. Assuming they did not get a headache, so no headache. So let's take a look at this. Here's our probability. Our probability is, we know that our condition is going to be no headache. I'm just going to abbreviate headache like this. Oh, how do you abbreviate headache? Oh, that looks terrible. How about if we just say HA for no headache? Let's make that a little closer. No headache. That's a little better. Still pretty ugly, but okay, no headache is our condition. And then assuming they didn't get a headache, they did not take the medicine, so no medicine. So no medicine. Now again, a lot of students will flip these around. I'm just going to show you. This, remember, this stands for the word assuming. So think about how by writing the probability this way, we kind of flip things around. Assuming no headache, how many did not take medicine? Or you could say the probability of not taking medicine or no medicine, assuming they do not have a headache. So now we look at our assumption part. How many did not have a headache? We've got 73 that don't have a headache. So that's our main group, 73. Of those people who did not get a headache, how many of them did not take the medicine? So of these no headache people, 25, did not take the medicine. So that's going to be our numerator. Now, you don't have to write all these things out, class. We've talked about in class where you can say, assuming they do not get a headache, and what you can do is you can just circle, here's no headache. We know that the numbers we're going to use for this particular probability only come from this row. So I'm showing you two ways to think through this. That's also a perfectly valid way to do it. So now my fraction is going to be 25. Oh, goodness, can't write a 2. Let's try to fix this and make it readable. 25 divided by 73. And that's going to be 0.342 or 34.2%. All right, last one. What's the probability of selecting a person that took the medicine, they took the medicine, or they did not get a headache? So now we have our or. Let's take a look at this with our or connector. Took medicine is a column, so I've got one column. Did not get a headache is a row, no headache. That's one row. And we are connecting these with the word or. That tells me this is an overlapping. Remember, if you have one column and you have two columns with the word or, then we know it's mutually exclusive because two columns can't overlap each other. If you've got two rows with the word or, that's also mutually exclusive. There is no double counting of those. But if you have a column and a row and you have the word or, that means that we know that we're going to have something that's in both the column and the row that's going to be double counted. So remember how we do this probability. We're going to find the probability that they took the medicine, and we're going to add to that the probability that they had no headache. I'll just put no headache, HA. And then we're going to subtract the probability that they took medicine and no headache. So in this case, remember, we're going to subtract the overlap because we're counting those twice. Let's take a look at this. What's the probability they took medicine? We've got 60 out of 100 took medicine. So 60 out of 100. Now we're going to add the probability that they had no headache. No headache is 73 out of 100. But if you look at this, if they took medicine and had no headache, you can see there's an overlap here. We got 48 people that we just counted twice. They're in the took medicine column. They're also in the no headache row. So we've got to get rid of that double count. So you've got to get rid of the people who took medicine and didn't have a headache, and that's 48 people. We've got to subtract out of here 48 are double counted. And then remember, when you add and subtract fractions, the denominator always stays the same. All you do is add and subtract the numerator. So 60 plus 73 is 133 minus 48 is 85. So our probability is 85 out of 100. That's 0.85 or 85%. Pretty good probability that if you pick someone from this group, they either took medicine or they did not get a headache. All right, hope that makes sense. Hope that explanation helps you. Let's do the next section, which is actually pretty quick. You can hopefully do this on your own. Hope you've done all of them on your own, actually. Number 6, choose whether the following data types are categorical or quantitative. Well, categorical means non-numeric. Quantitative means numeric or a number. So quantitative, I'm going to go through all the cues first. Miles is a number. How many miles? We went 5 miles. That's quantitative. Fish names, that's not quantitative. Those are actual words. Sales revenue, that's going to be quantitative. Like you made $1,000, you made $1,500. Your weight is quantitative. I weigh 100 and whatever pounds. Countries, those are names, so those aren't quantitative. Population, that would be how many people live in a certain area. That's a number. Phone brands, Apple, Samsung, those are not quantitative. Then college majors, economics, math, biology, those are not quantitative. So all of our quantitative ones are already labeled. That means fish names, countries, phone brands, and college majors are all categorical. And then question number 7, hopefully you're trying to do this on your own first. You want to show the relationship between miles driven and gallons of gas used. Gallons of gas used. Would you use a two-way table or a scatter plot? And explain why you think this is the best choice. Now, the way I look at it is this, class. Miles driven is quantitative. So is gallons of gas used. If you've got two values that you want to graph or put in the table, and they're both quantitative, you've learned that a two-way table is really good for categorical data, but a scatter plot is really good for quantitative data. So my explanation would be something like, I would use a scatter plot because both of the data items are quantitative, and a scatter plot works great for quantitative data. So there's question number 7. I'll end this video. We'll wrap it up on the next one with hopefully question number 8 and question number 9 together.